4.5, part 3. So this part is descriptive statistics. So there are two forms. There's central tendency and there's also variance. So central tendency is the single value to represent the data set. So measures of central tendency are numbers that describe what is average or typical of the distributions. So these are the mean, mode and median. So to find the mean out, you add all of your results up and then divide it by the number of participants that you had in the set. So the mean is used with either discrete or continuous data. It also includes every value in your data set in the calculation, and it's often used or is related to standard deviation. It's influenced by outliers, and it doesn't make sense in reality. So you can have a mean of 4.2, however you can't have 4.2 of a child or a participant, for example. And the mean cannot be used for ordinal or nominal data. So next is the mode, which is also known as the most common. So this would be the most common number you have in your data set. So for example, say you have a data set of 2, 3, 3, 4, 5. The most common would be 3, as there is 2 of them. So continuous data is less likely to have a common value or a mode at all, so it wouldn't be useful for that. And the modal value is dissimilar to most data in the set. So the last one is the median. So the median doesn't acknowledge the variation of data, so outliers aren't included. So this means that it's less affected by outliers. It's good with ordinal data. However, it's also slow to calculate if you have a large data set, as you have to put it all in order first for you to then be able to find the median. So the next part of this is the variance, which is the dispersion or the spread of data. So this will include range, interquartile range and standard deviation. So range and interquartile range. So the range, to work this out, is the max take away the median, the max take away the minimum, sorry. So in this data set it would be 21 take away 4, which is 17. The median would be n plus 1, so n is the number of participants, plus 1, and then it will be divided by 2. So in this data set it's 6. So it's here, letter H. The lower quartile range. So this is worked out the same as the median, so you do n plus 1, so number of participants add 1. However, you divide it by 4, because as previously mentioned, it's the lower 25% of the data. So this equals 5. The upper quartile range is exactly the same as the lower quartile range, except you times it by 3. So this is 15. So the interquartile range, that is the upper quartile take away the lower quartile. So in this case it would be 15 take away 10. Take away 5, which equals 10. So on the last slide, this was how you worked out the range and interquartile range if the amount of participants you had was an odd number. Because if you added 1 to this to work out median, lower quartile range and upper quartile range, it would then give you an even number, which would divide to give you an even number rather than a decimal. However, if you have an even number to start with, the answer you will get will obviously be a decimal. So to work this out, you first off need to find the median. The median is worked out completely the same as last time, so n plus 1 divided by 2. So in this case it gives you 5.5. Now 5.5 lies between the 5 and the 6 as seen here. So if you add a line between them and split the data sets into 2. To make this clearer, you can put brackets around them. And then next, you want to find the middle number in each side. So the lower quartile is 5, as it's the fourth number, which is the middle of 7. And next, the upper quartile is 10, as that's the fourth number as well, and that's also halfway between 7. So the lower quartile would be 5, upper quartile would be 10. So the interquartile range is worked out exactly the same as last time. Upper quartile, take away lower quartile, which is 10, take away 5, which gives you the answer 5. Next is standard deviation. So standard deviation is the spread of scores around the mean. So as you can see up here, we have a formula. So S represents standard deviation. This symbol here means the sum of. X here represents the individual score. X here is the mean, that means squared. N is the number of participants, and obviously 1 is 1. So first of all, let's work out the mean. So that would be all the scores in this column here, added together and divided by 14, which gives you 47.43. So next, you get all the individual scores, which is X in here. So here you would do 41, take away the mean, which we've just worked out as 47.43. And this gives you this answer here. To then reach this answer, you would then square it. So you do all of that for each individual row. Once you've got all of the data set, you would then add them all together. So that's the sum of. So you're adding all of these, which gives you 907.36, which is worked out here. So number of participants, as stated before, was 14. So take away 1 is 13. So put that into the fraction, divide it, which gives you this answer here, so 69.796, etc. You then want to square root it, which gives you the standard deviation of 8.35. And as said before, the standard deviation goes with the mean. So for nominal or discrete data, you would use the mode paired with the range. For ordinal data, you'd use the median paired with interquartile range. And for continuous, which is interval and ratio, you would use the mean and standard deviation. This is inferential statistics. So when choosing what test to use, you first need to take into account the type of analysis it is. So is it correlational or difference, as seen here on the table. Next, you need to know what level of data it is, so if it's continuous or nominal or ordinal. Next, you need to know if it's what kind of research design it is. So is it dependent, where the participants stay the same, or is it independent, where the participants change? And finally, you need to know if it's normally distributed or not. So there's 2 layers of analysis. So you have relationship and correlation. So this is the R value, which tells you the size and direction, and also the P value. So where P is less than 0.05, there is a significant difference. So the p-value in stats test is affected by the number of participants. So the bigger the sample size, will be more likely to find significance. The next layer of analysis is difference. So you have mean difference and then p-value. So mean differences is the practical meaningfulness, or percentage change, or effect size. So this is the first test. This is Pearson's rank order test that I'm going to be talking about. So as seen here, it's a correlational test and it's parametric, which means it's normally distributed. So up here is the formula that we are given for this. Obviously it's a very long formula. So to find our R value, on the top we have the number of participants, so in this case it was 8, times by the sum of the x variables times by the y variables. This is in a bracket, so it's then taken away by the sum of all the x variables times by the sum of all the y values. On the bottom of the formula, you have the square root of the number of participants times by the sum of x squared, take away the sum of x squared. Now, these two are easily confused, as they are both the sum of x squared. However, the first x squared, the sum of x squared here, in the first part of the bottom bit of the formula, is all of these x values here are squared, which gives you these values. You then add all of these up, and that gives you the sum of x squared. So that, in my example, is 811, would go there. Whereas this is the sum of x down here, which is 73 squared. So rather than putting 811 in, I'd put 73 in, and I would square 73, which gives me 5,329. On the other side, it's exactly the same, however, with the y variables. So again, number of participants, 8, take away the sum of y squared. Now, this is the same as before with x, but with y. So you have all of your y values, and you square them to get these values, add them all up together, and my answer was 634, which would be this part. That is then taken away from the sum of y squared. So this would be these numbers here added up, which gives me 66. So I would square 66, which gives me 4,356. So once the formula is done, you will get a calculated R value. So mine was 0.542. Now this value on its own doesn't have much meaning. We don't know if it's significant or not. This is when this table over here. So this is the table of critical values. And up here it talks you through it step by step. So to determine the row, you first need to calculate the DF. So that is the number of participants, which is 8, take away 2. So we get 6. So we therefore look down to 6 on this side here. And we go along to our level of significance for two-tailed, which is this part here. And our level of significance was 0.05, so it's here. We will then go down and match it up with 6, which gives us an answer of 0.7067. So if the calculated value we have, which was 0.542, is bigger than the critical value, there is a significant relationship or correlation, which means you reject the null hypothesis. If the calculated value, however, is smaller than the critical value, then there is no significant relationship or correlation. So my calculated value was smaller than the critical value, which means that there is no significant relationship between my two results.